Okay, we're going to focus on the domain and range of continuous functions. And that's really important because you can technically find domain and range of like just coordinates, but all of these are continuous functions. And what makes them continuous is essentially you have some kind of curve. And curves could be lines. They could be like this, curving, curve like that, or like a circle. It's a curve that intersects itself. What's interesting about this is if I tried to write the domain, and let's just quickly clarify. Domain is x values, okay? And then range is y values. That'll help us a little. Range is kind of your up and down stuff. How far does a function go up and down? And domain is how far does a function go left and right. If we were to try to write all the exact points that this circle hit, I'd be writing, let's do our best here. This is not very well done. 1, 2, 3. I'm going to say that this is about -4 and 1, 2, 3, about +4. We're going to say these are the major points. I know that is not quite the scale here, but we're going to give it some absolute values here, or sorry, some values to it. If we were to say, I want to name every single point, look at all the points there are. And then look at all the spaces in between that. I could be writing, like 1 and 2, and then 1.6 and 2.3, and then blah, 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 blah. I would be writing points forever because this is a continuous function. So when you get a function like that, it is redundant to do that. We never, ever do that. What we do instead is we make a statement, okay? So about this domain, I'm going to put D is x is the element of all real numbers, XER. And what that means is x is absolutely every number that humans know about, okay? Except if there's parameters, and there are parameters around this. The parameters here are the circle only goes all the way to the right, because we're checking left and right for domain. And the circle only goes so far to the left. In fact, these numbers are really important to our left and right. What's neat about them is we know this one, -4, is as far to the left as it goes. The function only exists between these, right? It has all these points. It has every single possible point between -4 and 4. So we say that x is every real number such that x is greater than and equal to -4. I've run out of room. I should write this somewhere else. I'm going to shrink it a little. I'm going to write it over here, okay? Domain is x is every real number such that, we'll start with -4, is less than and equal to x, and less than and equal to 4. And what that means is x is every number between -4 and +4.
But how do you know when to put the equal to?
Greater than or less than?
Like, how do you know if it's not just greater than?
That's a good question. And this here, in the very fourth graph, see how it's a point that's filled in? That means it's included. If you ever get something where it's a hollow curve and it does something like that, that means that exact point is not included. So you would say that that is just greater than, or if it's going the other way, you'd say less than. But if you have an included point, it's greater than and equal to, or less than and equal to if it's filled in. For the rest of these, I've made the assumption that it is hitting 4, and therefore it is equal to 4 also. Okay? If it's so visually difficult that it's hard to see, a teacher would most likely ask you just go to the closest natural number. And these are natural numbers. We're not going like 3.982 because we visually can't see that. That's too difficult for us. So that's the domain of the circle, but if we were to do the range, that's the up and down. Exact same concept, except we're dealing with how high and low this function goes. Same thing, I'm going to say the range is y is the element of all real numbers. Y is every possible number known to humans, such that, well, again, this thing tops out at 4 and bottoms out at -4. So we say -4 less than and equal to x, less than and equal to 4. If, I'm going to give you an alternative solution. If I wanted to write these signs the other way, I would just make sure that the smallest number is here and the largest, those are very poorly written words, number is there. And sorry, that shouldn't be an x. That should be a y because we're dealing with y. So it doesn't matter if I use greater than and equal or less than. What matters is just where I put the smallest and largest numbers in reference to our variable. So I've written the smallest one here, so I use a less than, and then y, and then a less than again. If I decided to write these the other way, I would just write my largest number here and my smallest number here. Both are correct. It doesn't matter which of these you use. You might have a common way that your teacher always uses less than. It's very common for me when I do it. I just write, because in English we read left to right, I just put the smallest to the biggest every single time. It doesn't matter though. Anything you want to do is fine there. So let's go to the next function. This one here. This is a linear function, or as close to a straight line as I can draw freehand. That means, in terms of domain, does this have any restrictions going left and right? Are there any restrictions to this? No, it's going to go forever. So the domain, that is a D, is x is the element of all real numbers. Finished. There are no parameters. It's going to go there forever, so I don't have to write anything else. I just say it's every possible number.
Even if it's just like a squiggly line and 2 arrows?
Well, this is, you know what, this is a great point. I'm going to call this question 1. This is 1. We're focused on graph 2. So this is just the domain of graph 2. When we go to 3 and you're talking about 4 here, we'll talk about what the possibilities for 4 are.
But if they're both arrows?
So if they're both arrows means they go forever.
Oh, so it's always that if there's 2 arrows?
2 arrows, always that.
Okay.
And then we'll talk about the parabola here, the third one, how it changes one of either domain or range. Because this is, again, a linear line, the range of the function is y is the element of all real numbers. That's it. Okay? A linear function goes up and down and left and right forever. Nothing can stop it. Okay? Graph number 3, domain. Once again, it's continuous, so if anything's continuous, x is the element of all real numbers. Now, here's the question. Do parabolas, so this one's a parabola, let's say, do they stop left and right? Does anything technically stop them? No. So again, this is XER. It goes on forever. X is the element of all real numbers. But this is where it gets a little trickier. Range. It's continuous, so we say y is the element of all real numbers. These arrows are pointing which way?
Down.
Both are pointing down. That's really, really important. What is the highest point here? And I should really write that in. Ooh, I really like the number 4 apparently.
4.
4 is the highest point. So
anything is smaller than?
Excellent. Y is less than and equal to positive 4. Okay? It has no bounds below. It goes on forever, but it does have an upper bounds. It has a ceiling. Or a floor, if you think of it the other way, and the ceiling is at the number 4. Okay? Here's the hardest one. Graph number 4. Domain. It's continuous, so we start with x is the element of all real numbers, but something stops it here. Okay? And again, I didn't write any numbers in. I wish I had a real graph. I'm going to say this gets to about negative 10. Okay? So on the left side of this graph, it's negative 10. It's the farthest to the left. It has an arrow going to the right, which means it never stops going to the right. So for our domain, we say x is the element of all real numbers such that x is, and in this case, it is greater than and equal to
That point?
negative 10. That exact point. If it was hollow, right? If I had just have, like we talked about here, if it was like that hollow thing, then I would say x is greater than negative 10. I wouldn't put the equal sign if it's hollow. Okay? Hollow represents it's right there but doesn't touch this point. The range, though, here's interesting. Range, again, y is the element of all real numbers. It also has, looks like that dot is the lowest point also. Okay, the arrow is pointing upwards here, so it looks like it has no upper bounds. It's going to go upwards forever. But the lowest point is 1, 2, 3, 4, 4. I don't know. We're going to say negative 5. Okay, is negative 5, and is it go up from negative 5 or down?
Goes up.
Up. So y is greater than and equal to negative 5, and there's our range.